students, I am Dr. Nimi Singh. Today I bring you the next learning episode. In this episode, we will discuss about the examination of paint at the scene of crime and in the laboratory. We will then wind up this lecture with a conclusion. Dear students, we studied about paint, their chemical composition, classification. You also got to know about the class and the individual characteristics of the paint. In addition to it, you were also acquainted with the importance of paint in various cases and how paint evidences are collected, preserved and handled at the scene of crime. So, let us have a look at the modules which we will be learning today. We will learn about the examination of paint at the scene of crime and the examination of paint in the laboratory, the preliminary and the confirmatory examination. Then we will conclude. Now, let us come to the examination of paint at the scene of crime. The paint is a very fragile form of evidence having utmost importance in the field of forensics, as it can relate the suspect, victim and the crime scene with each other. It is encountered in many cases of hit and run and in thefts and burglary cases. Hence, it should be collected, packaged and handled carefully at the scene of crime. But when it comes to examination of this evidence at the scene of crime, there are certain main concerns which are to be taken care of, such as the type of case or investigation, the sample size, the environmental effects, complexity and condition, the collection methods, etc. These factors actually guide the forensic examiners to choose different methods of analysis for each specific case. Moreover, paint films are characterized by various physical and chemical properties. The physical properties include the color, layer sequence and thickness, surface and layer features and contaminants, while the chemical properties include pigments, polymers and additives. These features can be determined by various macroscopic, microscopic, chemical and instrumental methods. Difference in appearance, layer size, thickness, etc. can exist even in samples of known origin. So, the absence of certain significant features in an analysis may suggest that the paint samples are from common origin. Once the sample for the paint analysis is recognized, it is then removed manually with the help of various lifting and cutting methods. Then, the analysis for the paint sample is done taking into consideration that the methods used should be more specific and less destructive, rather than considering methods that require more sample preparation or consumption. These analytical techniques include pyrolysis, gas chromatography, scanning electron microscopy, energy-dispersive X-ray analysis, X-ray fluorescence and X-ray diffraction. But one thing has to be kept in mind, that before we proceed in for chemical or instrumental analysis of paint chips and smears, physical or preliminary examination is very necessary. As far as the examination of paints are concerned at the scene of crime, it being a fragile evidence is collected and packaged carefully and the color is noted. The number of layers can also be determined, but only to some extent. The main examination is carried out in the laboratory only. Coming to the examination of paint in the laboratory. Now, there are two types of examination, the preliminary examination and the confirmatory examination. With the help of paint analysis, it is easier to identify the possible make, model and year of manufacture of motor vehicles from the paint which is collected at the scene of crime or accident. It is also possible to differentiate motor vehicle repaint from the original equipment manufactured. Once the evidence is recognized, try to remove it manually before tape lifts to collect evidence. It is collected with tape lifts very carefully. being aware of the difficulty encountered while manipulating the paint samples bearing adhesive residues. If the contact between any two coated surfaces is indicated, then there is a possibility of cross transfers. As a result, it is made sure that the samples from both the surfaces need to be collected. Paint flakes can be removed by a number of methods like lifting loosely attached flakes, cutting samples of the entire paint layer structure using a clean knife or blade, dislodging by gentle impacting the opposite side of the painted surface, etc. Once these formalities are complete, then for paint analysis, the sample size, condition and layer structure complexities is to be considered while deciding as to which technique is to be used. Samples which are neither restricted by the amount nor by the condition should then be analyzed in such a manner that the analysis will actually determine the color and texture of the paint as well as the number, order, colors and texture of the layers in case the sample is a multi-layered sample. After successful collection of the paint evidence and proper packing, it is then sent to the laboratory with the purpose of examination. So, analysis or examination of paint sample can be carried out in two ways: the preliminary examination and the confirmatory examination. Let us take up these two examinations in details one by one. Let us first come to the preliminary examination. The preliminary examination or the initial examination of the paint evidence comprises of color assessment, especially the hue, the human eye and Munsell color system. The paint evidence comprises of different shades of color. The usual color can be determined by the naked eye, but the variety in color shades or its gradient is determined with the help of Munsell color system. The number, sequence and thickness of layers, sequence of colors and the thickness of different layers present are observed and noted with the help of a microscope. A combination of stereo transmitted light and a polarized light microscope. This is done at magnification of 2x, 200x to examine the layers in paint. Now, many layers will be visible without preparing the sample, but definitive paint layer identification often requires some sample preparation techniques. Coming to the surface texture of the paint. Now, the surface characteristics of the paint evidence can be easily studied as how much rough it is or how much glossy the surface is. This parameter can also be studied with the help of a microscope, which is again a combination of stereo, transmitted light and polarized light microscope. Now, coming to matching the physical irregularities. Now, scratches, contours that are continuous with the known and unknown, the physical fit of these two paint chips. Here, we will take up a detailed discussion on physical fit of two paint chips. Now, let us come to the physical fit of two paint chips. Here, we will take up a detailed discussion on how physical fit of two paint chips is considered. As with any other examination, the initial step in forensic paint flake analysis is to simply look at the sample. A stereo microscope is an invaluable aid in this process. Often, the first step may be the last if significant differences are apparent in the known and questioned samples. The analysis is complete and the paint is excluded. Microscopic examination is the most effective method for the identification of paints. Bigger chips are separated from sample and any possible physical matching of the broken edges of the chip in the exhibit and the control sample is then done. Physical match is the most conclusive type of examination that a forensic investigator can perform on paint samples. It involves the comparison of edges and surface striae between samples. Now, both the edges and the stria in question must possess unique characteristics. When imaging methods are used to document a physical matching, then the forensic examination should make sure that the method employed is dimensionally accurate and has associated measuring scales. It should be made sure that the images are well preserved and retained as part of the documentation. It can be said that physical matching is the most effective method for identification. Samples are first examined under a good stereoscopic microscope and other overall similarities are then noted. Bigger chips are separated from the sample. Occasional physical match between two such samples prove beyond doubt that both the samples have a common origin. Let us see how matching of layers are carried out. Automobile paint chips mostly contain several layers. The edge of a chip may cut with a laser blade or in a microtome and mounted vertically with the cut edge upside in a plasticine or similar mount. Sequence of color and thickness of different layers present are then observed and noted. Brittle paint chips may be mounted on a paraffin block and then sectioned with a microtome for comparison. Layers from two paint chips may be compared in a comparison microscope. Exact matching of layers in a multi-layered chips establishes their identity. Important points to be kept in mind while carrying the matching of paint chips should be: in very small paint chips, cutting of the edge may not be possible. So, in such a case, the paint chips may be mounted directly or layers should be studded. The old repainted vehicle may have difference in layers in different parts of the same vehicle. Therefore, non-matching of layers does not always eliminate the possibility of two paint chips being originated from the same vehicle if they are found to be similar in other confirmatory tests. The brittle paint chips are sectioned with the help of microtome for the purpose of comparison under comparison microscope. Let us understand now in brief how a microtome works. The paint layer structure can be seen by cutting through the sample with a scalpel blade at an angle. This technique increases the visible area of the sample. So, the structure of the layers and any irregularities and inhomogeneities are typically easier to see after this sectioning. After this sectioning, very thin sections of the paint can be accomplished with a steady hand and a fresh scalpel blade, a device called a microtome. A microtome is a mini device that holds a sample in place while a heavy and a very sharp glass or diamond edged knife slices off sections a few tenths of microns thick. Cross sections of the paint samples either embedded in a material for support or thick section preparations provide information about the layers, their thicknesses and the colors in addition to the size and the distribution of pigments. Embedded preparations work well because the sample is easily handled and can be subjected to many analytical techniques with a minimum of additional preparation. After the preliminary examination of paint evidence, we will now be studying about the confirmatory examination. The confirmatory examination comprises of certain chemical and analytical techniques. That is the microchemical test, the differential solubility and TLC, the TLC analysis, infrared spectroscopy, mass spectroscopy, Raman spectroscopy, polarized light microscopy, gas chromatography, pyrolysis gas chromatography, Xray diffraction, scanning electron microscopy, energydispersive Xray analysis. Let us now discuss each of them. Come to the microchemical test first. These tests are used to discriminate between paint films of different pigment and binder composition which are already similar in visual and microscopic views or appearance. These are based on pigment and binder color reactions with oxidizing, dehydrating or reducing agents. These tests should be applied to both questioned and known samples concurrently. The effect of these tests has to be recorded immediately. Reactions such as softening, swelling, curling, color changes are some features which are to be noted properly. Entire layers may dissolve or disaggregate, pigment filters may bubble or fizz or flake apart, called flocculation. apparent color change may be seen in some layers. These triads are not clear-cut results that are easily quantified. These results are then primarily used for preliminary classification and comparison. These tests may be carried out in Prochlin spot plate. About 2 square millimeter or 3 mg of the sample is to be put in each of the well. Then the following reagents are added: concentrated sulfuric acid, that is H2SO4, concentrated nitric acid, HNO3, concentrated hydrochloric acid, HCl and sodium hydroxide, NaOH, that is acetone, diphenyl amine reagent. Change in color or bleeding of the color, solubility, effervescence of the gases, scaling out of the layers, and any other such peculiar behavior has to be actually carefully noted. These tests have been used to discriminate between paint layers of different pigments and binder composition that are otherwise visually similar. The basis of these tests is that the different layers of paint have a different chemical composition and will therefore react differently with oxidizing, dehydrating or reducing agents. Now, the problem with these tests is that they are destructive and should be applied to known samples first in order to know its efficiency. So, these tests should be used only in situations in which the quantity of question sample is actually adequate. Now, differential solubility and TLC. Solubility of the paint samples may be tried out in a number of solvents such as acetone, ethyl acetate, chloroform, benzene, methyl alcohol, methylene chloride, dimethyl formide, xylene. After solubility test, the solubility or partial solubility of the sample is then noted. The soluble component of the paint may also be examined by thin layer chromatography using appropriate solvent system. Now, coming to infrared spectroscopy. Since the paint fragments are small, so Fourier transform infrared spectrometer is recommended. Out of transmittance or reflectance techniques, it is the transmittance technique which is preferred, as most of the binder pigments have emission spectra. In this type of spectroscopy, samples of individual layers is prepared using scalables, blades, forceps, etc. and placed on a small plate or an appropriate mount, and then analysis is carried out. Coming to mass spectrometry. The technique of mass spectrometry is a famous and powerful analytical procedure employed for the quantification of known samples and for identification of unknown compounds in a sample. The whole technique comprises the conversion of the sample in the form of gaseous ions with or without fragmentation, which is then further characterized by their M to Z ratio or mass to charge ratio and relative abundance. The applicability of this technique depends on the paint type, layer complexity and the amount of sample consumption that can be tolerated. Now comes the Raman spectroscopy. This technique is based on the scattering of light rather than the absorption, unlike infrared spectroscopy. So, in this case, the results are totally complementary to those from infrared spectroscopy. Some paint samples may give rise to both infrared absorption bands and Raman bands, but their intensities will be different in both the techniques. Now, coming to polarized light microscopy. This technique is used for examination of layer structure and also for the comparison and identification of the particles which are present in a paint film, including pigments, additives, contaminants, etc. It involves the use of polarized light. The basis of this technique is the wave nature of light. Polarized light microscopy is based on the fact of the polarizing light. In polarized microscope, there are two filters. One is a polarizer while the other is the analyzer. Light from the source moves towards the polarizer and then is analyzed at different position of the analyzer. That is, the two filters can be rotated in different positions depending on which the spectrum will be formed. If the two filters are rotated in exact opposition, that is perpendicular to each other, then no image will be seen. Thus, with the help of second filter, that is the analyzer, different vibrational forms of light will pass through the sample. The different appearance of how light behaves on impinging through different samples of paint is made use of in determining the composition of the paint sample. Coming to the gas chromatography. Now, chromatography is a laboratory technique which is used for the preparation of mixtures. In this technique, the mixture is dissolved in a liquid known as mobile phase, where it is carried through a structure holding another substance known as the stationary phase. The different components present in the mixture travel with different speeds, making them to separate into their individual components. In the gas chromatographic technique, the carrier gas is chosen as the mobile phase, whereas the inert gas is opted, such as helium or unreactive gas. It can be any unreactive gas, for example, nitrogen. The stationary phase is the microscopic layer of liquid or a polymer, but on an inert solid support inside a piece of glass or metal tube called a column. The instrument used for such a technique is called gas chromatograph. Coming to pyrolysis, gas chromatography. This is a destructive method of chemical analysis in which the question paint sample is heated to decomposition to smaller molecules, which are then separated by gas chromatography and detected using mass spectrometry. Here, pyrolysis means thermal decomposition of materials in inert gases or vacuum. The sample is put in direct contact with either a platinum wire or placed in a quartz tube and heated rapidly at 600 degrees centigrades to 1000 degrees centigrades. Large molecules then break at their weakest point and produce smaller or more volatile fragments, which are then analyzed using mass spectrometry. The patterns of peaks in the known and question sample chromatograms, also called pyrograms, are compared, and the peaks must coincide for the identification to be determined. The resulting reconstructed total ion chromatogram may help to identify additives, organic pigments and impurities in addition to the binder components. Coming to X-ray fluorescence and X-ray diffraction techniques. These are both non-destructive techniques. Because of the penetration depth of the primary X-rays, the X-ray fluorescence analysis yields elemental data from several layers of multi-layered paint fragments simultaneously. This analysis can be used qualitatively as variations in layer thicknesses cause variations in X-ray ratios of elements present. X-ray diffraction technique is used for the identification of the crystal form of pigments and is not soluble for organic pigments. This technique is based on the emission of characteristic X-rays after excitation of the sample by an X-ray source. Coming to the scanning electron microscopic energy-dispersive X-ray analysis. This technique is used to characterize the morphology and elemental composition of paint samples. In this process, an electron beam impinges over a selected area of the sample, producing emission of various signals including X-rays, backscattered electrons or secondary electrons. The emitted X-rays produce information regarding the presence of specific elements, while electron signals produce compositional and topographical visualization. Let us come to the conclusion now. Paint is a very fragile form of evidence, yet having evidentiary value in the field of forensics. For the purpose of examination, it needs to be preserved properly. In addition to it, proper precautions need to be exercised while carrying out chemical or instrumental analysis on these evidences. Now, with all this information, here we come to end of today's lecture now. Do keep in mind what we have discussed today. So, I will be back with one more lecture in this series. If you want to learn more and enhance your knowledge, you may log on to our website www.cec.nic.in for MCQs, quizzes, LORs, etc. Thank you for your time today. I will see you in the next lecture. Have a great day.